All right. Hello, everyone. So today is April APSCE webinar series. I'm Jae, ladies and gentlemen. My name is Jae Moon. I'm currently assistant professor of instructional technology at the University of Alabama, United States. It is my great pleasure to introduce our esteemed speaker for today's APSCE webinar, Scaffolding in Game and Problem-Based Learning and our DBR story of EcoJourneys. Please join me in giving a huge round of applauses and extending a warm welcome to Dr. Hansel Bae from the University of Alabama, Albany State University of New York. Our SIG in APSCE, Educational Games and Gamification, gratefully invited our speaker in the honorable APSCE webinar, and I'm very happy to moderate this event. Dr. Wei is an accomplished assistant professor at the SUNY State University, at the University at Albany State University of New York, where her research brilliantly interweaves problem-based learning, artificial intelligence, and teacher education in STEM field. She delves into fascinating ways teachers can support complex and learning processes by leveraging the power of emerging learning technologies. Her projects include the development of classroom orchestrations for collaborative inquiry learning in a game-based learning environment, and then co-design of a locally relevant AI curriculum that seamlessly integrate ethics-centered AI literacy to deepen our understanding and assessment of AI's profound significance and ethical implication. We are truly fortunate to have Dr. Wei here with us, ready to share her vast expertise and invaluable insight on design and iterative refinement, blends the aspect of a collaborative inquiry with problem-based and game-based learning together. Dr. Wei will deliver captivating 40 and 45 around minutes presentations, followed by we are going to have a dynamic 20 minutes questions and answer sessions afterward. As a moderator, I'll be actively monitoring Zoom chat throughout the presentation. Everyone, please mute your speaker and listen to her presentation, and then you will leave your questions in the chat. We encourage your active participation. Look forward to lively and enlightening discussion. Once again, big thank you to Dr. Wei being here with us today. The stage is yours.
Thank you, Dr. Min, for amazing introduction. It was really, really good to hear what I have accomplished. So I'm going to share my screen and slideshow. Do you guys see my screen? Okay. Okay, great. So thank you so much for having me. And it's like the title says, it's a scaffolding in game and problem-based learning, our DBR story of EcoJourneys, meaning it's a long story. And then it's about 7 years of our developing this game-based learning environment. And then it's long, but I want to make sure that I'll deliver all this story within 40 minutes. So I might, I don't know, like skip some specifics, then you can write down in the chat so you can ask more about it. So there you go. So I'll start with some definitions. PBL, what is PBL? About ambitious learning practices and collaborative engagement, and then go to DBR story, and then more specifically how we design the scaffolding systems to support collaborative learning. Then there's another thing that we are currently working on is designing a orchestration assistant or dashboard, however we call it. It's a classroom orchestration. So that's going to be my talk. So let me start with this. Education today must focus on helping students learn, how they can manage, so they can manage the demands of changing information, technologies, jobs, and social conditions. So when we think about, for example, ChatGPT, changing information, technologies, and future jobs, and how we need to teach and learn. So this is actually all about, the goals of education, and that's what we lead to go to a framework for problem-based learning. So and then this framework starts with ambitious learning practices. So by ambitious learning practices, we mean learning environments that are student-centered, as you can see in this great chart, collaborative, and require extended engagement with meaningful problems or questions. Then there's collaborative disciplinary engagement. So this goes beyond individual conceptions of engagement to consider engagement as collaborative and multidimensional, and goes beyond time on task, also considers the collaborative interactions, social emotional climate, and then cognitive engagement, because they have to monitor what they're doing, as well as how deeply learners are participating in this disciplinary practices and working with disciplinary concepts as tools for their problem-solving inquiry. It's pretty complicated, but let me unpack as we go. So the class of inquiry-based learning methods that engage learners in collaborative problem solving and reflect authenticity in the discipline. So ambitious, and then so that's what collaborative engagement means. And then let's go to, in our project, we work with partners, meaning the K-12 teachers, because that are our end users of our project, and also with who we want to support and work with. So we value participatory co-design process for personal, local, and cultural relevance, and a sense of group belonging. So we work with educators and learners, students, throughout the design process to get input and feedback on our designs as we develop conductors for design and enactment. But then one of the challenges in doing this work is a balancing between learner agency and providing appropriate structure or support, giving students authority to solve problems. It was really difficult to design this type of balanced structure, because we want to make sure that students are not frustrated or are not confused in this inquiry environment. But then also at the same time, we want to make sure that the support is not too much or not too closed. So that way the students will have their ownership and their agency to solve their problems on their own. So balancing this two mechanisms, scaffolding was really it was interesting and challenging for us. Then this now we have to leverage scale up this learning environment. So think about it. So when you are teaching maybe like 5 students, and then you're the only teacher, but with 5 students, you can do, collaboratively, like teaching them, oh, what do you think? What kind of evidence did you find? You can manage that environment. However, when you are thinking of your classroom, I don't know how many students in your country, but normally in traditional setting, there will be maybe 25, 30 students, and then there's only one teacher. So when we think about the scaling this up this ambitious learning practices for diverse learners, meaning beginner learners, or there can be advanced learners, and also multilingual situations. So in that situation, we want to leverage some technologies that can help the process. And then here we are trying to leverage artificial intelligence that can foster meaningful collaboration, engagement, and learning, so that we can take advantage of productive and generative qualities of our AI and provide meaningful context. And like I said before, this distributed scaffolding, meaning here distributed by the teacher, or it can be even peer scaffolding, but also it can be through the system or tools. So this interplay of facilitator and learner practice coupled can structure and managing complexity, and also problematizing learning, problematizing, I'm not sure if you are familiar with this term. Structuring and problematizing are kind of the opposite. Structuring means making the problem space more easy, unpack the situation. But then problematizing means that we make sure that students go deep in the problem just in case that they miss some important concepts, or if they just stay on the surface level. Okay, let's talk about this. And do you agree? Yeah, let's move on without discussing, deeper understanding of the concepts or reasoning. And then transferring responsibility to learners so that the students in PBL, the ultimate goal of a PBL is to make sure that students become independent so they can do their own inquiry without scaffolding or without facilitators' support. So that's the scaffolding part. But then, like I said before, there has to be a support for classroom orchestration. So this is related to scaling up the learning environment. So when there are so many students and so many tasks to do, which is usually normal for a lot of K-12 teachers. So we are also trying to reduce orchestration load and support inquiry process. So it can help educators manage individual, group, and class needs and leverage multimodal learning analytics in ways that are actionable for teachers. I can go back all these details in the later slides, so I can go back there. And then to provide guidance and assistance to educators so that the teachers know where, who they need to go and give support, and when is a good time to go, and how is a good way to engage in specific situations. So that's about the classroom orchestration. So now let's talk about the DBR, design-based research. This DBR refers to iterative development and refinement of a narrative-centered learning environment. So in this case, we were working on the narrative-centered learning game environment. And then we focused on designing systems of scaffolding. So we were not just designing the game-based learning environment only, but we were also focusing on building systems of scaffolding. And then so that we are bridging the PBL principles, inquiry cycles, but also at the same time, the principles of game-based learning by designing game. And then CSCL, because they are all working on their each computer using, the game. So this was the whole our DBR concept. So let's go. So far, this is really big picture of our project, and this is our kind of product so far. So the game name is called Crystal Island EcoJourneys. The context was, this was for middle school students, 6th grade, and then for science class, and then problem-based learning, and there's authentic inquiry. So they have to solve a problem. And what is a problem? The fish is dying, the tilapia is dying. So they have to find out why tilapia becomes sick in this island. And then they have to find this as a group. So there is a collaboration piece in it too. And then, but some challenges that we faced and then we want to address is orchestrating these complex classroom activity across multiple levels, because there will be whole classroom discussions or whole classroom presentations. But then there's also small group, there's usually like 7 groups in this environment. And then there's also individual inquiry. So the teacher has to know, what this individual student is doing, but then what this group 1 is doing, and then, but then also the teacher has to know how the whole class is understanding and how much gameplay they are doing. So there are lots of orchestrating work to be done. So that's why that was one of the challenges. But then there's also the students. So you can imagine that each student is just facing, just like you are playing any computer games. So each student is looking at their own screen. And then they are supposed to talk to each other through chat while playing games. And then there's no way that the teacher will find out what they're talking about or where they are, how they're doing. So it was really challenging to evaluating how they're doing and also interpreting the information about student engagement. So that was one of the challenges that we were also trying to address. So specifically our game structure was like this. So it started with the tutorial, and then there were quests 1, 2, 3. So tutorial starts with the introduction of game narrative and then function, like just like other Zelda games. So we have a tutorial that tells you, okay, if you go here, you will see this, or if you want to do this, then click here, stuff like that. So that was in tutorial. And then, but still, we wanted to make sure they are learning something and they're engaging in a problem solving. So the first tutorial problem is, what is a green slime? So we made sure that the students go to this beach and then they have to go to this green slimy thing that they have to collect, and then they are going to go to a lab and then they are going to analyze. So that was the green slime is. And then explanation, the blue green slime is a cyanobacteria, but of course we are not telling to them at all. It's just something that they have to find out through discussions and data analysis. So quest 1, so as you can tell, as the quest goes, it's the content level becomes more complicated. So quest 1, they're engaging in why is the water cloudy? And then the explanation that we want to hear from the students is the water is cloudy because of dead organic matter. But then quest 2, why are the fish swimming at the surface of the water? So they will find this, they have to observe all these throughout the game in the island, and then they will find, oh my God, why is fish swimming here? And then they have to find out why through the data. So here, the explanation that we want to hear is the tilapia are swimming at the top of the water because the water is cloudy. Oh, so it's related to quest 1. So they have to remember what they talked about and what they collected so far. Then there's quest 3. What is the impact of the cyanobacteria on in tilapia health? And this explanation, it requires them to think about all the notes that they have taken and all the data they have collected. And then the explanation that we want to see is the tilapia is sick because of the lack of oxygen in the cloudy water, and the lack of oxygen is due to organic matter. So, you don't have to read all these, but this is how we structure the game. And then original conjecture mapping in early development, the design work was centered on embodying the process of collaborative inquiry in the story. The high-level conjecture was that successful collaborative inquiry learning depends on engagement with inquiry. We hadn't yet thought a lot about the teacher at this point, but had planned some Wizard of Oz studies with human facilitators, meaning there was no system prompted scaffolding in the earlier version. At that time, like me, we were just there and acting as a wizard character, and we were just prompting them, But later, now version, there is a system generated prompts that just the NPC, they all provide the scaffolding. As far as the problem space went, the kids wanted to be middle school kids, and then they did not want to be any kind of experts such as scientists or journalists. They felt that would be too much pressure. So we went through several paper prototypes, and then, and from the early version of some whiteboard, and then learn what to do, what to include in the whiteboard systems, and then I'll show you later version. And then this was an iterative process. So and then later as you can see, we even went very detailed about what to design for each scaffolds. So each conjecture was like meaningful joint task. That's what we just discussed. But then there has to be communication space, that makes student thinking visual. And then also scaffolding is needed for productive collaborative activity. Then collaboration requires boundary objects and then support for teacher orchestration. So we expanded from this to really, really complicated version. And then I'll show you the next what happened. So in the problem-based learning, the whiteboard, so this is whiteboard, what we call it whiteboard, has a central space as a boundary object for students to negotiate what they're understanding, as well as providing a macro script to support the PBL inquiry cycle. So like what we know, what we need to know, stuff like that. So this was a very early version of whiteboard that was used in the medical school. And the second panel, this one was the brainstorming board. We called it brainstorming board that asked students to take the information that they had and connect it to factors that tilapia need to survive. Then this was our initial work. So this work showed a tension between doing PBL, real learning to learn, but then also to be playful. So we wanted to make sure it can be playful. I don't know if it's playful for you, but that's how we designed. But then we also noticed that this brainstorming board was a little bit too close-ended, meaning there's a answer. Actually, there was answer. So there's a right or wrong answer, and then there was not really a place to really go above and beyond and discuss about this. So we moved to this tide board. I'll explain later. So here, this is our current version. It's tide board. So this is the environment for the EcoJourneys, and this whole 3D environment had this type of graphics around the island. So let's dive into EcoJourneys. So it starts with this: your adventures, it's about to begin. So this is a web-based multiplayer game. Students are transported to a fictionalized island in the Philippines where the economy is driven by tilapia farming. And then they found out that they have to solve a mystery of why the tilapia are dying at alarming rates. Then they meet this Maria. She's a lab assistant or scientist. Yeah. So the cycle of inquiry for students is one of which they independently perform individual exploration in the environment. Go walk around. You see this all these houses and the and the beach. So they have to walk around and collect the notes and some dirty water or green slime, stuff like that. So they have to do that. But then they have to gather with their team collaboratively to make sense of their investigation. So each person might get some slightly different information, stuff like that. And then at this point in the investigation, students work independently, and then they have to just use this jeepney, and then they go from like hatchery or rice field, stuff like that. So this is the hatchery. And then they have to, yes, go get the water, and then they have to check the water level, and then they are sending it to the lab. So measuring, so that's what the dissolved oxygen mean. It was. So in our 2D version, we didn't have this type of animation. And then I personally really like this because even though it's a educational game, it kind of shows some, more game-based learning image, so I like it. And then you also arrive at Floor's farm, explore for a little bit, so they can explore, and then they can find. Actually, there's some dirty water right there. Right there. And then you notice some blue-green slime. And then take a note. So that's how the game is structured. But then there's a collaborative data analysis, and then it's called deduce. You can see. So you can see that like table and numbers and dissolved oxygen numbers. So here, students collaboratively look at the collected data and negotiate to reach agreements in the Deduce app in the game. So, and then they have to know how to read all these tables and understand what this really means. And then sometimes there's like a quiz. So once students have collected water samples from among various sites, they perform guided investigations. I don't want to call it quiz, it's a guided investigations to determine what is in the sample. And each team will see they agree or not. So they don't really see, the game wouldn't really see correct or not correct, but each says if it's like 4 of the group members agree or not. So if they don't agree, they have to discuss why. So in that way, they will, share what their understanding, and if there was any misunderstanding, they can help each other to understand. And same thing, lab tank samples. And then they go to, so after deduce, they have to go to the TIDE board. And then this is TIDE. What do you think TIDE stands for? Talk, investigate, deduce, and explain. It's right there. So they have to chat, talk through, and then they have to bring notes. So notes are the notes that they collected in the game. So they bring their own notes, and then they have to talk about the notes in this TIDE board. So in this structure, we are thinking of scaffolding on 3 planes, like I briefly explained in the beginning. Individual support. So, like I said, so there are 6 groups and then 4 students in each group. And then it makes 4 times 6, 24. So it's pretty big class. And then there's only 1 teacher and everybody's looking at their computer. She doesn't know what's happening. So that's why we were like, oh my God, how are we going to support the teacher so that, she knows what is going on and then she knows how to support the teachers. So the students. So individual support, then there's also a small group support, and then there will be a whole classroom support. And then also another way students receive information that is now driven by AI, it's in their group chat. So this is the group chat. And actually this design looks a little bit different now, but this chat consists of each group member plus an AI agent who supplies adaptive scaffolding to the group. In this case, a group member is approaching the tilapia hatchery and need to remember critical information about respiration. This is important because as students are collecting water samples, they are also making sense of the complex and dynamic ecosystem. In other words, the system is, queuing just-in-time information at a critical moment. So they have to, so the AI can detect if they are understanding what they are supposed to understanding or what they're supposed to talk about. So can someone here, wizard is the AI. So can someone tell me about respiration? Then another student can say it brings in oxygen. So that is one of the scaffolding design that we are working on right now. And also there's a fixed scaffolding. So in the Deduce app, I don't know if you can read here, but disagreement with teammates answers. So like I said, so if they don't disagree, then the system will generate this type of message like, or if it's not correct, then also this system generated message will be like, looks like all the team members agreed. Okay, they're all, okay, you're right, but some of your responses are not correct. So they have to go back and do it. So this system will trigger that as well. And in Tideboard, same thing. Nice work. The Tideboard looks good to me. So if it's good, then it also says it's good. And then there's also something that we worked really hard is sentence starters. So it's during the tutorial, and then complete your sentence with one of the sentence starter examples. So what we found from our earlier version testing was that the students didn't really know how to do inquiry. They didn't know what really problem solving is, other than like, hey, how are you? like they didn't know how to do scientific inquiry. So we wanted to make sure that they have some scaffolding to support their inquiry process. So here, conversation starters is like, does anyone agree with my idea that blah blah blah? So there will be dot 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 in the chat. I would like to introduce a different idea, which is, or can you explain why you think that? My reasoning is, so stuff like this. And then these sentence starters were designed based off from accountable talk. So this accountable talk is a really useful framework to talk about inquiry like discourse. And then this has three big buckets. And then the first one is accountable to community. So they have to share their ideas when they do inquiry reasoning, and they're accountable to reasoning. And then they have, can you explain why? So they have to make sure that they do logical reasoning, then also accountable to knowledge. So what is the evidence to support? So we wanted to make sure that the students touch on this type of discourse. So we started with sentence starters, and long story short, not a lot of students use the sentence starters because it was option to use. So that was not really fun, but we have here. And also now we are talking about adaptive scaffolding. So fixed scaffolding here, fixed scaffolding was just given to anyone, like at the same time. But adaptive scaffolding is triggered by the conditions of, whatever we designed. So standard deviation of chat messages. So we wanted to make sure that these, like, so for example, there are 4 students, and then we wanted to make sure that, the students are equitably participate. So if, the chat message was not really evenly distributed, then we made sure the system will trigger somehow. And also there was a group satisfaction survey right after each quest. And then they can make sure, how frustrated they are or how satisfied they are about, some specific collaborative inquiry process. And then the NPC, the game character will later deliver this type of message. Like, for example, I received feedback from your group about how you are working together. As a reminder, your group thought it would be good to work on something that they, chose as a problem. So this type of scaffolding is adaptive to each trigger condition. So that's also made in the game. So this is that I just talked about. So it's actually really bad design. I'm so sorry. Can you find a note that you think is consistent with Sulu's explanation and explain why? So when they're not talking about why, so much, then this type of system provided scaffolding can go in there. And then collaborative sentiment is just like I said, I received feedback from your group about how you're working together, and then oh, it's good to work on regulating problem solving. So that's how we designed. So I didn't really talk about the whole picture, but this work was done when I was in Indiana University, and then our partner school was North Carolina State University, and then they were like a tech team, I want to say. They did all the development, and then we were doing all the education part. So for example, this type of narrative, we wrote everything. We wrote all the messages and the narrative. We wrote everything, and there's a tool called Ink. That's how we used, and then it's actually from my end, we just it's a Google Doc. So we just, hey, can we change to this? Then okay, I'll just go change. So it was really a smooth transition for us, but it was a great experience to learn. So I don't think I have time to talk about that, but that's how we did. And then this was also an early version of our scaffold. So I'll just skip this because we don't have a lot of time. So what have we learned in the classroom when we actually implemented this this learning environment. So this was one of the classrooms in Bloomington in Indiana, and then it was really big class. There were 30 students. And then for our research, we usually bring all the computers for the students, and we install all the students and these cameras for each group and stuff. So it's a really, really big scale of research. So from paper and then 2D version, then now it's a 3D multiple games. And then we refined like whiteboard, and we also worked on the forms and functions of scaffolding. And so that's what we've been doing and still learning. So we are actually writing about this DBR story right now, and then our paper is getting like too long, so we're actually it's pretty challenging to make it short. So let's talk about scaling up this EcoJourneys in PBL classrooms. Like I said before, there is a big orchestration load. There can be. It imposes great challenges for teachers because it's really demanding for the teacher to monitor the inquiry process and interactions of all these multiple groups of students. And that means it's pretty challenging to also provide timely, appropriate scaffolding that is contingent on and adaptive to each group's ongoing needs. So, and then if the group is doing really, really well, then you also don't want to provide any scaffolding because you don't want to stop the good flow going. So we thought it's really like difficult to design a tool to do stuff like this. So we were thinking of this kind of big question, like how can artificial intelligence technologies support teachers in their work to support student engagement in collaborative problem-based learning and game-based science learning. And we started with the teachers to design a orchestration assistant. We call it OA. And then we did lots of interviews and to find out what they really want to see. And then they wanted to have, like if there are many things, but if we make like three big chunks, they wanted to conduct assessment and they wanted to intervene and scaffold in different ways. For example, some teacher wants to even control students' screens if the students are not, following the directions, stuff like that. And then they wanted to visualize information for them to understand what is going on. So real-time progress, idea development, level of engagements. So but then we also found out that there was some tensions between what teachers want and the designers or researchers want. So the teacher wanted to assess, they want to evaluate what they know, like right, wrong, like ABCD. But as a researcher, we wanted to make sure that, the orchestration system is not a assessment tool, but this is more to supply the most valuable information to help their instructional capacity. And then the teachers wanted to compare individual student participation and progress and rank them. So, okay, who is the number one group? Who is number one student? However, we wanted to promote more collective, like collaborative reasoning process rather than individual competition. So that was the tension that we had. And also, the teachers wanted to quickly obtain the level of group productivity through quantified indicators. So it's related to the second one. They wanted to know like, okay, how many percentage? Like, they wanted to quantify like description, but then we wanted to make sure that we don't label the teacher, the students or the student groups to represent, because group dynamics is not like good or bad or slow or fast. There can be more interrelated factors. And then we are still thinking of what is a good way to represent this type of, diverse ways of participation. So that's what we are working on right now. So the designing an orchestration assistant, we came up with there would be a before support and concurrent support that you're looking at right now, and then there will be a reflective, like retrospective support, and then there will be, it's actually not built this way at this point, but this was our storyboard that we made, and then there will be some chat center, and the AI can help. Group 2 seems to need help right now. Ryan in Group 2 is mostly contributing the chat and other members are silent. What would you like to do? So what we are thinking is the AI can actually learn the teacher's style too, because every teacher is different too. So that's what we are trying to build as well, but we are not quite there yet, but that was our idea. And then also after the class, the teacher can see what actually happened, and then this is like a rundown of like summary of what happened that day, like investigation, how many minutes, introduce, incomplete, and where they are, scientific discussion. So to make this happen, we are also capturing students' interaction data through multimodal learning analytics, like motion tracking, facial expression, gesture, gauge tracking. So that's one of our team's current project right now. So let me wrap up this. So what are we doing here? Why are we working on this? So I want to make sure to go back to I want to pull back from a moment here and then take stock of why we're doing what we're doing. As a reminder, part of the motivating idea behind all these EcoJourneys and using all these AI is a commitment to educational equity for a diverse range of learners. So technology that reduces demands and supports teachers, but then also that avoids biases and deficit conceptions of marginalized learners. So these two key designs we are making to enable. So I wanted to make sure to talk about this. So supporting educational equity by prioritizing human-centered automation. So like our team did, we started with co-designing because we wanted to make sure the teacher is a primary decision maker who engages this consequential pedagogical and scaffolding actions. So place focus on what is not automated and what to say to whom and when. And it can free teacher time and enable, their deeper scaffolding. But then when we are building this OA, we wanted to make sure that we are using limiting labels deliberately. So it means we wanted to make sure that we use descriptive, informed, comparative models in the hands of teacher, but not diagnostic. So good or bad, fasten. We didn't want to make we didn't want to use this limited label, and then don't let automation do what it does best. Categorizing, sorting, label. So we want to make sure that we don't design something like that, and also, like I said before, enable the teacher to re-specify norms and goals, because every classroom is different, every country is different, every teacher is different. So we wanted to make sure that AI or this technology just doesn't take over and replace. So what do you guys think? How can we design educational technologies in ways that make this ambitious learning available to and effective for all learners? So this is the question that I wanted us to think about. And then this is not everyone is here, but I really appreciate all these great people who've been being involved with great big projects. So I'll finish in here, and I can share some information, these links with you guys, and then you can also email me if you have any questions. So I'll stop here.
Thank you. Thank you, Dr. Fei. It was a great presentation regarding the blends of game-based learning and then problem-based learning. Actually, it was quite interesting and then very informative. As a beginner of the PBL, even try to incorporate that the game-based learning in PBL. I was really impressed by that the ideas, groundbreaking ideas to really merge that the two ideas together, with
Mm,
considering that the teacher orchestrations is a
mm,
very human-centered design considerations in a learning science field. I really appreciate. We have one questions from audience, so I want to read.
mhm.
Maybe, yeah. So Ati, Sushi, Dian, Martha, yeah. So the question is, I'm curious about the wizard. How does scaffolding work on the AI? Do you only provide the information when students ask, or provide the direction slash guidance too?
Mm,
I think that
ask.
she was, yeah, talking about the wizard, the systems in
Right.
games.
The so how it works at this point is the system, so the good thing about this game-based learning is um when they're playing, every click, every action event is logged, and then this OA is real time, like monitoring those. So AI can be triggered based on how we make the model, and then so it's not just about only when students are asking to the AI, but it's actually always monitoring what students are doing, and then the AI will decide, oh, hey, So is not talking. Let me talk to her. Then in my chat, the AI will, you know, oh, what do you think of, XYZ that was mentioned in my group chat? And then I can answer to the AI. But honestly, I we are still testing, so I don't really know if it's effective just yet. But one way we did is before AI, we also did the rule-based chat systems too. So we made, we wanted to make sure that the students are not just playing around. So we want to, we have some like a bag of words, and then they have to hit those, target words. So, and then that was reflected in the dashboard. So you, oh my God, the students are so creative. And then they play tic-tac-toe in the chat. They do karaoke in the chat. Like they just sing each other. So um I analyze, like, I don't know, 10,000 lines of these chats and stuff too, and then it was pretty funny. So it's it. So that's why we made some model, but AI is not always so correct. So then if it's not like 100% relevant, the students will just ignore.
Yeah, I totally agree that the educational game is always, and then throughout the gameplay, they are not learning always. Probably, I think some portion of the time they are investing is really just for fun.
Mm-hmm.
But actually, we also have to really admit, or surprisingly, the random guessing is also kind of a major component or the patterns, as the
Mm-hmm.
students also have some things during their gameplays. So I think that you really corroborate that these patterns in the game-based learning. Great, great. And probably in the meantime, while waiting for the other comments, I also have a question.
Mm-hmm.
Actually, it is not for the presentation limited, but probably I think that I would like to ask for your experience designing, because we are trying to explain that the journey, right? The
Mm-hmm.
echo journey of the journey, design journey of echo journey.
Yeah.
So, in your experience, what is the key and the critical factors? I know there are so many challenges ongoing, but that contribute to what is the most insightful or memorable, successful problem, some factors that you think that, oh, and this you should really take care of while you're developing the blend of PBL and then game-based learning. What do you think?
I think it really is the narrative, the
Mhm.
story, and the like designing of the question. It takes a long time. So it was, and then once it's done, it's really hard to change. So Cindy, oh, I didn't mention it's anyway, Cindy Mello Silver, she's a PI of this project, and Krista Glazinski, she's a PI of this OA project. And then Cindy still is complaining how close-ended this game is. But we cannot make this game just open-ended like, I don't know. So we are still battling like, is this too open-ended or is this too close-ended? But if it's too open-ended, we cannot really make this as a learning environment, I feel like. So we want to make sure it's structured enough so students know where to go. And then, I mean, even though it's very closed, the students always go to like some weird sandbox and like always like hitting something on the wall and they are not doing anything anyway. So I don't know. So making a really great story and the problem like inquiry design, I think that will be the most important thing. But then it comes with how in a scaffold, how are you gonna design the boundary object, like how are they gonna work on, it all comes together, I think.
Great, great. So, and then the following questions, based on your presentation, is you said that the project team was also developing the adaptive scaffolding. But actually, the definition of adaptive scaffolding needs more clarification to me. Actually, what kinds of adaptivity are you guys really considering here? Is that task of difficulty or just the response of the AI reaction? Or how you really just to control that the profiles of students or behaviors of students? Is it really macro level adaptivity or just micro level adaptivity or just both sides? So I was just curious
I
about
guess it's
adaptivity
kind of
here.
mixture of those two, but I think one thing that is kind of unique to this is it's always the individual versus that group. So we always compare how that individual is doing versus the group is doing, then how this group is doing compared to the whole class is doing. Only because, so one thing that I also wanted to mention is the sustainability of NSF project. So when I see this type of NSF project, like how can I say it's not widely just used just yet in other classrooms because we are still developing and it does require pretty powerful CPU and all that. But and then this AI and more technologies, it's gonna be even harder. I don't know what I was going to say. Um but adaptivity, so oh yeah, so that's the portion. So we wanted to make sure we are building something that is applicable and actionable and practical to real classroom. So, all these adaptivity is based on what will a teacher want when they implement this. So it's very like specific to this like individual to group, then group to the whole class. That's how we structure it.
Awesome, awesome. Actually, I know you are not only researchers in problem-based learning, but also you are doing really, really actively doing some AI education research as well.
Oh,
So probably, do you have any future direction to really incorporate that current study findings into your future research? And what is your future research that really get some takeaways from the current study finding?
great question. So this definitely pushed me to go into more AI research and then make sure how we can leverage AI, this amazing technology, to make sure it is doing a good thing for the society. So that really goes back to the last a few slides that I was talking about, to use how to design something that is human-centered or using limited labeling, because I don't want AI to be used to always, screening and just labeling without humans touch. I know why Jaeyoung is smiling because, because XYZ. I will know because I know him, but maybe AI will think that he's being silly. And I don't know, like I think there definitely has to be some smart and humane decisions to be made. So I am very interested in more designing work. So currently I am building a AI tool. I don't even want to call it AI tool, but a learning environment that supports climate change education in climate change, and then it uses local data sets to analyze, and then learn about climate change. And then doing that, each group can use this type of chatbot so they can, it's like support. So if you are interested in any of these, you can actually, there's a video that we made about this. Wait, can I do everyone?
Probably, yeah, I think that this chat for only for panel.
Okay. So if somebody can, maybe the host can help me widely spread these. I'm also guest editing a journal special issue, and it's called Humanizing AI for Education, Navigating Social, Cultural, Psychological, and Ethical Dimensions. It's in a Journal of the Learning Sciences. So if anyone who is interested in AI and then thinking deeply about, this topic, please take a look at this link. I'm sure we can share this through the society. And
Yes.
then, yeah, okay, great. And the paper abstract due is June 30. So if you were wondering what you're going to do during summer, please consider this great opportunity and email me if you want to talk or, connect.
Mm, Wonderful. Actually, today we really addressed the very interesting marriage between the problem-based learning and game-based learning. Actually, I was very intrigued by ideas of taking the both advantages of each side. That presenting scenarios with a narrative or immersive learning environment context through gameplay. Also, they're trying to provoke their critical thinking and then literacy through collaborative inquiry under the umbrella environment of problem-based learning context. I think it is still very challenging to really manage everything, but it will be also very exciting opportunity for researchers also working on this field. I really appreciate every that insight you share and then advice. I think that it will be helpful for the educational game and gamification researchers and also learning scientists and then instructional design technology researchers as well. So thank you so much, Dr. Bae. And then I think that before ending up the sessions, I want to give a heads up to our upcoming webinar hosted by APSCE. Actually, it was also great. It would be also a great opportunity to learn internet ethnography for education. Will be presented by Ryan Ebardo, de La Salle University in Philippines. I think that I'm sure that it will be also very interesting resources and then event for everyone in APSCE society. So we are going to also check in this event afterward. All right. So that's all we prepared today. And please give a big applause to Dr. Vale again to just having us host this insightful event for today. We are going to revisit the other events maybe next month. Thank you so much.
Thank you. Thank you so much.
Bye.
Okay.
Should I?